this is our first example for an empirical formula problem. In our first tape, we showed you the steps for solving empirical formulas. Now we're giving you an example. Step 1, transform the given values, convert the given values into grams. If you're given, like in the first line, 1.52 grams of nitrogen and 3.47 grams of oxygen, if you're given grams, you're done already. Excellent. However, these problems sometimes give it to you in percentages. So if you're given 20.2% aluminum and 79.8% chlorine, it's no big deal. Simply cross out the percent symbol, put G, and now you have grams.
Good.
Okay, now that we have grams, we're going to use dimensional analysis, periodic table, and a calculator, and we're going to convert everything into moles. So, 20.2 grams of aluminum, go to the periodic table, you see it's 26.982 grams per mole, invert that, use dimensional analysis, we end up with 0.74865 moles of aluminum. Same thing with chlorine, 79.8 grams of chlorine. Periodic table, you end up with 2.250 moles of chlorine, grams to moles.
Good.
Okay, so now that we have moles, you want to take a look at your moles. Divide the value by the smallest one. So our moles of aluminum, 0.7485. Moles of chlorine, 2.25. 0.78 something is much smaller. I divide each by that. So 0.748 divided by 0.748, 1 mole of aluminum. 2.250 divided by 0.74865, 3 moles of chlorine.
Good. Next one. And go.
Okay, so we just got done dividing those numbers by the smallest one, so you have a number of 1 and greater than none. Write the whole numbers for each as a subscript to the atom. So the aluminum was a 1. We don't write 1, we just leave it alone. So it's Al. And chlorine had 3 moles, so that subscript becomes a 3. So aluminum chloride is AlCl3. This is the empirical formula. Just because it's also the molecular formula doesn't mean anything in particular. Sometimes they are, sometimes they're not. This is the empirical formula.
All right. I think that's it, right?
Yeah, that's all I have written up. Give me 5